While the many available slicers for 3D printing offer a variety of differing features, they all fundamentally rely on planar geometry, and that one layer of the print needs to finish before another one can begin. While this typically does not cause problems in the majority of prints, some structures, particularly those of smaller scales, are impaired by this process. Approaches to address this issue have commonly taken the name universal slicing, which refers to combining the litany of possible alternatives to layer based printing that researchers and designers are now exploring. While many non planar geometries would benefit from universal slicing, I explored two in particular that I believe demonstrate the key structural and physical properties that make alternative slicing so valuable. In addition to their functional benefits, these prints also required significantly less time to print than their sliced counterparts due to the saved travel time of the printhead. The first structure, a small table or stool, supported by vertically printed legs, demonstrates the difference in tensile strength of the structures when printed with the traditional slicer and when printed with the novel approach. While the traditionally sliced leg is brittle and weak, the vertically extruded leg is flexible and durable. The second structure, a spring, demonstrates another property that can be achieved with universal slicing that cannot be implemented with layer-based printing. While a typical 3D printed spring in PLA is predominantly rigid due to the stacked plates that comprise the coil, the continuously extruded coil exhibits the typical bounce and springiness that we would expect from a small aluminum spring. These physical properties are particularly important for compliant mechanisms in which the structure of the print itself dictates the degrees of freedom through the similar intentional under-extrusion or over-extrusion of the filament. This further opens up new design possibilities that otherwise are inaccessible with 3D printing. The central limitation of this approach is the printhead itself. A key benefit that layer-based slicing provides is the assurance that the printhead will not encounter any previously printed structures, since it continuously moves upward in the z-axis. This approach, which requires the printhead to move fluidly in all three axes, encounters problems when printing adjacent structures, since the printhead can damage the print while in motion. This requires careful ordering of the printed parts and a detailed knowledge of each printhead's geometry. A simple solution to this bottleneck would be the creation of a long nozzle for extrusion of this nature, so that the printhead could remain well above the print. The structures explored here, however, are only a minuscule portion of the new printing modalities that universal slicing offers, and with increased investment from the 3D printing community, universal slicing can become more widely available.